In this lecture, we are going to see the relationship between electric field and magnetic field when a electromagnetic wave propagate in lossless dielectrics. So you see that there is a certain relationship. The first is that E and H are perpendicular. Electric field and magnetic field are perpendicular. Second, E and H are in phase. E and H are in phase means what? The ratio of E by H is real and its value is called intrinsic impedance, that is eta, and that is equal to under root mu upon epsilon naught, and mu is mu naught mu r and epsilon is epsilon naught epsilon r. When you write the value of mu naught and epsilon naught, you will get eta is equal to 120 pi under root mu r upon epsilon r. If we assume lossless dielectric to be air, in that case mu r is equal to 1 and epsilon r is equal to 1, and eta that you will get 120 pi. So this we have to prove first that E and H are perpendicular when electromagnetic wave propagate in lossless dielectric, and second that E and H are in phase. E और H जो है सेम फेज में होता है, मीन्स व्हाट, E और H जो है रेशियो है वो रियल होता है, दैट यू हैव टू सी, दैट वी विल प्रूव दैट. ठीक है. So we start from Maxwell's equation. We are writing Maxwell equation here, that this is Maxwell equation first, second, third, fourth in a lossless dielectric. So whenever we want to see the relationship between E and H, either we take equation number 3 or either we take equation number 4. So I am taking here equation number 4, that is the curl of H epsilon del E by del T. This is the modified Ampere's law in a lossless dielectric. Let Z be the direction of wave propagation. We are assuming that electromagnetic wave in a lossless dielectric is moving towards Z direction. In that case, for uniform plane wave, we take Ez is equal to 0 and Hz is equal to also 0, and in that case E and H will be in xy plane. So del by del x that will be equal to del by del y, that will be equal to 0 because waves are uniform in nature. So here we write the value of curl H in determinant form. We are writing here Hz will be 0, del by del x will be 0 here, del by del y will be 0. So I have written here 0 0, and right hand side epsilon del by del t Exx plus Ey Ay. You compare component wise for x component and y component, you will get this equation number 1, and for y component when we compare we get this equation. Now suppose we are knowing the value of electric field, then what will be the value of magnetic field we want to know. So suppose the x component of electric field for uniform plane wave, we write like this: Ex is equal to F1 Z minus Vt. We are assuming that Ex varies like this, so I am calling this as a F1, capital F1. Now then del Ex by del T we will calculate in expression number 1. In expression number 1 we will write the value of this del Ex by del T like this. Then I will put this value here in expression number 1. So del Hy by del Z epsilon V F1 dash you will get. Then I will integrate this equation with respect to Z. So when you integrate this equation with respect to Z, you will get Hy is equal to epsilon V F1, that is F1 is nothing but Ex. So Hy is equal to epsilon V Ex. So if Ex is known to us, then we calculated the value of Hy. Remember, so suppose this is equation number 3. Now you take equation number 2. Now I am assuming Ey, because I am assuming that I am knowing the value of E. So Ey is equal to, suppose it is a F2 Z minus Vt, the wave that is traveling towards Z direction with velocity V. So that is I am taking as F2. So differentiate with respect to t, you will get this expression. You put here this value here, you will get del Hx by del Z, that is equal to minus epsilon V F2 dash V is the velocity of wave. When I integrate this expression with respect to Z, I will get Hx. So here you will have this expression Hx is equal to minus epsilon Ey. This is the fourth expression, and third expression Hy, if we know the value of Ex is this. So for known Ex and Ey, we calculated the value of Hx and Hy. Now we have to show that E and H are perpendicular. So for that we will calculate dot product of electric field and magnetic field. So I am taking here electric field and magnetic field dot product. So electric field E vector dot H vector. So E vector is Ex plus Ey Ay, and H vector is Hx plus Hy Ay. So I am writing here the value of E vector and H vector. So that is equal to Ex Hx, this is the plus sign, this is a mistake, this is the plus sign. Ey Hy you will get, this is the plus sign, dot product you will get plus sign. So now you write here Ex, the value of Hx you write here. So Hx, that is minus epsilon V, Ey you will get, and here this is the plus Ey, that is Hy, you write epsilon V Ex. So this is a plus sign, you correct it. So this is minus and this is plus, that will be cancelled. Means what? E dot H is equal to 0 means what? E and H are perpendicular. E and H are perpendicular in a lossless medium. So if this is electric field value, then magnetic field will be perpendicular. This is electric field and this will be the perpendicular magnetic field, and this will be the direction of a propagation. Now second characteristic, we have to prove that E ratio of E and H is real. So we take the E by H, magnitude of E and H. So magnitude of E is under root of Ex square plus Ey square. H ka magnitude Hx square plus Hy under root. So we put here the value of Hx is this, so epsilon V Ey whole square. Then here Hy, that is equal to epsilon V Ex whole square. Epsilon V square we take it out from here. So this Ex square plus Ey square will be cancelled out, and you will get E by H ratio, that is equal to 1 upon epsilon V, and V is the wave velocity in a lossless dielectric. So V is equal to under root mu upon epsilon. When you put that, you will get the E by H ratio, that is under root of mu epsilon, because it is the ratio of E by H. E is a volt per meter and H is ampere per meter. So we will get the units of volt per ampere, volt divided by ampere. So that is nothing but impedance, that is in ohm. So we call it as intrinsic impedance of medium, intrinsic impedance of lossless dielectric, that is equal to this quantity. Now if lossless medium is air, we take case of air. In case of air, we put here subscript naught, eta naught or 0. So eta naught, that is equal to E by H. In that case mu r is equal to 1 and epsilon r is equal to 1. So that is equal to 1 point. So intrinsic impedance of air value is 377 ohm or 120 pi. So we proved this two characteristics, that E and H are perpendicular and also E by H, because here we are not getting complex quantity. So the ratio of E by H is real. It means E and H have no lagging effect. They are in phase. If this ratio is real, means what? E and H are in phase. This will not be the case of conducting media. In conducting media, E leads H by approximately 45 degrees. So that you have to see when electromagnetic wave propagates in a conducting media. But for here, for a lossless dielectric case, E and H both are in same phase. E and H जो है same phase में होता है. There will be no lagging or leading between electric field and magnetic field. Electric field will start at the same time as magnetic field. So there will be no lagging effect, phase lagging or leading effect. So you see these two important characteristics, that E and H are perpendicular and E and H are in same phase. In the next class we will see the electromagnetic wave propagation in conducting media.